This video demonstrates the fundamentals of wired serial data communication using Arduino. Wired serial communication uses line coding to transmit data from transmitter to receiver. One type of line coding is non-return to zero coding, NRZ coding. The NRZ signal is generated by using a clock signal and the data to be transmitted. So for every clock pulse, the data is made available at the output, and here we will get what we call the unipolar NRZ signal, and the logic 1 pulse is called the mark pulse, and the logic 0 pulse is called the space pulse. There are other types of line coding used in serial data communication, which will be covered in future videos. NRZ line coding is simple and uses lesser bandwidth compared to the other line coding schemes. A block diagram of the implemented system is shown here. We have two Arduinos, one as a transmitter and the other as a receiver. The transmitter will transmit bytes of data to the receiver using a wired serial data line. And there's also a clock line which is used to synchronize the data at the receiver side. The clock line is connected to interrupt pin 0 of the receiver. We also have a push button connected to a digital pin of the Arduino, which is used to transmit the data from the transmitter to the receiver. And we have two LED indicators, one for the clock and one for data. The transmitted data and the received data are displayed on the serial monitors of the Arduinos. This first demonstration shows the transmission of 10 bytes of data when the transmission button is pressed. And now at the receiver side. A quick look at the C++ code used in this project for the transmitter part. The code main reference is videos by Ben Eater on the subject of data communication, which I highly recommend checking out his channel. We have this one-dimensional array which contains 10 bytes of data to be transmitted. The data type of the elements of this array are of byte type. Inside the loop function, when the transmit button is pressed, this function is called and executed. Inside function transmit data, we have a for loop here that will loop 10 times to cover the 10 bytes of data to be transmitted. Inside the for loop, the first thing we do is to copy the first byte within the array into this byte variable. Next, we use this for loop that will loop 8 times to extract the bits from the byte. And we do this by using this statement here, which will extract the bits starting from the most significant bit. Once the bit is extracted, we output the bit to the serial monitor and also output the bit to the data line of the Arduino. These two statements generate the clock pulse, which are sent through the clock line of the Arduino. So this inner for loop will transmit the 8 bits of the byte, and this outer for loop will transmit the 10 bytes of data. This is the receiver code. Again, the reference here is Ben Eater. Within the setup function, we attach interrupt 0 to pin 2 of the Arduino. When the receiver detects the clock pulse, interrupt 0 occurs, and this ISR is executed where the received bit is saved. Inside the loop function, this if statement becomes true only when the receiver detects a clock signal and then the received bit is displayed on the serial monitor. In a future video, the system will be modified to include channel coding for reliable data communication. Thank you for watching.